welcome back, Weekend Warriors, to the AI Scouting Report Part 2. What's up, Eric?
Hey, Nathan. Stoked to get into Part 2.
Just to kind of set ourselves up for, where we left off. Part 1 was all about setting up how we got to kind of this AI moment, and I've really come to believe more and more recently that given the existence of web scale data and web scale compute, that it was really only a matter of time before somebody figured out an algorithm that was really going to work. And the algorithm that we figured out first, that seems to be generalizing to just about everything that we try to use it for, is the transformer. And we went through the architecture of the transformer and the parts and covered a lot of the jargon. And then for me, the most interesting part was getting into what we can really say about what they do and don't know. And obviously that led us to a discussion of grokking, which is this generalization and apparently very real, even if sometimes alien, conceptual understanding that is definitely more than just memorization. And we can see that because we're able to kind of, in some cases, even reverse engineer the algorithm that the transformer has learned and break it down and show that, this really is a general solution to the problem. So that brings us to this, interesting moment where these frontier language models like a GPT-4, they know a lot of stuff, and it's unclear in many cases whether they know that because they've kind of memorized statistical correlations and they're still operating in the stochastic paradigm, or whether they've truly grokked conceptually whatever the subject matter is and have really learned something in a robust way. So that debate rages on. And I think, every month as we look at updating this, already since the publication of Part 1, there have been some incremental grokking results, and people continue to, really explore what do they and don't they know, where are they guessing and where are they really coming to understand conceptually what we're asking them to do. But today, Part 2 is going to be much more practical, much more applied. Now that we've got these large scale language models like a GPT-4, what can we do with them and how do we overcome the weaknesses that they have so that they can actually start to do really useful stuff for us? And that is where this recent trends part kicks off. How's that sound?
Sounds great. Let's get into it.
First big trend, number 1, is the rise of custom hardware that is specifically engineered to support AI workflows and increasingly transformer architecture specifically. So this one, the H100, is the new hotness from NVIDIA that is just really starting to ship, and people are starting to build the first clusters of these H100s right now. It is a chip that is even more purpose-built. In fact, really arguably the first kind of NVIDIA product that's truly fully purpose-built for an AI workload. As I understand it, all their earlier stuff, the GPU comes from graphics processing unit, and they were really in the graphics business for the bulk of their life. Graphics processing, as I understand it, actually needs more general purpose compute than the AI workloads where it's really just the matrix multiplication that we covered last time. And the bandwidth in some of the earlier chip designs was not so much the ability to do the computation, but actually just getting the data on and off the chip. They call that interconnect, and that is just, literally shuffling the data in and out so that it can be processed. And that became such a bottleneck that they created a whole next generation of chip to address that. And these H100s are that next generation of chip. NVIDIA is not alone in this space. We did an episode with Andrew Feldman, who's the CEO of Cerebras Systems, and they built the world's largest ever chip, which really uses the whole silicon wafer. I remember him showing that, holding it up and showing it to us in the context of that interview. But NVIDIA, of course, does still dominate the market today. Just that they're, increasingly inspiring competitors like Cerebras, like Microsoft building their own chips. Meta has their own chip project. Google has the TPU that they've, been building for years. And so just in general, across the board, all these big tech companies, plus some, inspired startups, have recognized that there's a lot more hardware to be built. And we're entering a new regime of hardware right now where a lot of the scaling problems that were such a pain in the butt to solve before are just getting much, much easier. Starting to see some headlines too from these H100 initial deployments where it's like, look at how much faster it is to train this stuff on an H100 versus the A100, which is the prior generation.
I was going to say, we're seeing startups raise a lot of money, and it's rare that startups usually raise a lot of money before they have a product. But, things like Dan Gross, Nat Friedman are kind of subsidizing it. Like talk about what's different here as it relates to building one of these companies that requires to raise so much money as it relates to getting these.
This is a significant physical capital infrastructure if you're going to buy a bunch of these chips and set up your own cluster. So probably the biggest headline from the last couple of weeks on this was Inflection AI raising 1.3 billion. That's the raise to, in large part, buy a ton of these chips and set up their own, world-class, top-tier supercomputer cluster. So that is an indication that those guys plan to be in the game, in a serious way for a long time, obviously, and they don't want to be beholden to anybody else for, their ability to train their next models whenever they want to train a next model. And it sounds like they plan to do a lot of it. It has, it's not easy to make the most of a supercomputer. It's a whole realm of engineering in and of itself that's kind of independent largely of the language model work. It's kind of like you got to come up with the architecture, you got to develop the machine learning science of making sure that your AI is actually learning stuff effectively. But then to scale it out, you have to manage this cluster, and if it's thousands of chips that you're managing, there's a lot of complexity just in that. So it's kind of like $1.3 billion raise is a big raise, right? This is largely the space of big tech and like really well-funded companies. OpenAI, raised their $10 billion, and they're partnering with Microsoft on this, so they're going to have top-notch access. Anthropic, has raised a ton of money and is partnered with Google, so they're going to have top-notch access. In their case, it'll be presumably Google's TPUs as opposed to the NVIDIA line of products. But this is not something that's easy to crack into, and it doesn't mean that you can't build an AI company or great AI product without this kind of stuff. But if you want to do foundation models at the scale that it looks like it's going to take over the 24, 25, 26 timeframe, you're going to be buying a lot of H100s.
There was a famous or a viral exchange where someone in India asked Sam Altman if an Indian company or other companies can compete with OpenAI and foundation models. And Sam said, hey, look, I'm going to tell you that you can't, and you're going to tell me that you can. Do you think that the foundation model game is the existing players have too big of a head start, or do you think there are companies that we don't know about yet or that are just emerging that are going to become major players?
Very good question. I don't think we should expect to see too many more, probably. I mean, but then again, sometimes I do feel like we're all kind of thinking a little too small. When I look at things like character AI and Inflection's product is Pi, and these are these like very different kind of language models that aren't really work assistants, but they're more like companions. In the case of Pi, it's like a very friendly kind of back and forth. In the case of character, you can make it anything you want. I had a conversation with Elon Musk about Kurzweil's Revenge. And, that might be the kind of thing that we all just end up like spending a ton of time with our AI friends, or our AI friends join our real social lives, or who knows exactly how that ends up playing out. And so maybe there is just totally new dimensions to it that, nobody has considered yet, that somebody will kind of burst onto the scene and create. But they're not going to do it on a frontier basis without a lot of capital, right? I mean, if they're fine tuning other people's stuff, this is kind of the next slide. But if you're fine tuning, you can get away with a lot less. But if you're building foundation models from scratch, it is going to take a lot of resources. Interestingly, also, these H100s are banned from sale to China. That presumably, if it holds and if it can actually, keep Chinese companies from accessing this technology, which, will be its own kind of cat and mouse and enforcement regime, yada, yada, yada. But if they can, then that would presumably mean it's going to be really hard, no matter how much money or state backing they have, to scale up to the same degree that the leading companies in the West will be able to scale up, because it's just really hard to do without this next generation of technology. So here's the history of fine tuning. This is the other kind of, the next super big trend. The history of kind of using language models over the last couple of years. And we did an episode with Riley Goodside, world's first prompt engineer, who took us through this history as he experienced it as kind of a gonzo AI journalist, and took us all along for that ride on his Twitter feed. The history kind of has three phases to it in terms of fine tuning, and then I've also broken this down into kind of three tiers of investment and scale. So the first tier and the first phase is the pre-training. That is basically saying, okay, we're starting with a blank slate. You remember last time we talked about how the parameters, aka the weights, aka the numbers in a transformer that are sitting there waiting to be used to transform input data, those numbers in that transformer are typically initialized randomly or pseudo-randomly. So initially it's kind of garbage in, garbage out. You set that up and you start this pre-training process. And we talked about the next word prediction and how each word on the internet now becomes, an opportunity to learn, because you no longer have to have labeled data. You can just use all the raw text with next word prediction as your loss function. That is called unsupervised learning. And you are throwing a ton of data and a ton of compute at your process to scale up to a modern cutting edge transformer. Typically, the kind of entry level at this point for like a small llama model would be 1 trillion tokens. That's 1 trillion times that a next word has been predicted, and that, that output prediction has been scored. And then, the back propagation, adjusting of all those weights to improve the prediction for next time. It's 1 trillion cycles of that. And again, there's a lot of complexity. They're batched and there's a lot of efficiency measures. But 1 trillion tokens is 1 trillion predictions. That's the whole internet. It's all the books. It's kind of everything you can get your hands on, or at least it's most of it. There's obviously, significantly more still, because per the most recent rumor, GPT-4 reportedly was trained with 13 trillion tokens. So I didn't change the slide on that because that's still a unconfirmed rumor as I understand it. And the budget on these is also, kind of a closely held secret, but general understanding is that GPT-4 cost $100 million plus. I think Sam Altman has confirmed that much. So, from the smallest 1 trillion tokens and maybe a $1 million-ish budget up to 10 trillion tokens and $100 million budget, that is where, obviously you're going to need a lot of chips to support that whole massive unsupervised pre-training process. What you get out of that is illustrated here with this giant monster. And it's basically the sort of world's largest autocomplete phase of AI, right? It's this just kind of weird, whatever text comes next, whatever representative text on the internet, that's all it knows. And I'll show you an example of that on the next slide as well. After that comes a layer of fine tuning. And this, I think, more than anything else, has been the big unlock over the last, say, 18 months, starting with OpenAI's publication of Instruct GPT, which was January of 2022. At that phase, they were just using supervised fine tuning, also known as instruction tuning, which basically means that they create a bunch of samples where the user gives instructions and then they show what the language model is supposed to do, what good looks like in response to those instructions. And they basically just continue the same process of training. It's still just next word prediction, but now the data set is not just all the text on the internet, but it's very specifically demonstrating to the AI how to follow instructions. And so the behavior that creates is that it will follow instructions when you actually go to use it. So then the next step on top of that is this reinforcement learning from human feedback. And this is kind of all the rage, at least conceptually lately. It allows you to, or requires you to, I should say, first collect a bunch of feedback from humans. Then you create a reward model based on that feedback. What the reward model does is guess, based on a certain input, what the human score would be. So the first thing is just attempting to learn to mimic the human scoring. That in of itself is a big challenge because it's noisy. people do not agree what the right response is. There's a lot of difference of opinion between this output and that output, and lots of, tools and an effort to kind of figure out how to make that as consistent as possible so that the reward model has the clearest signal to learn from as possible. But it's a noisy process, definitely an imperfect process.
Hey, we'll continue our interview in a moment after a word from our sponsors. Hey, everybody. If you're a business owner or founder like me, you'll want to know more about our sponsor, NetSuite. NetSuite provides financial software for all your business needs. Whether you're looking for an ERP tool or accounting software, NetSuite gives you the visibility and control you need to make better decisions faster. And for the first time in NetSuite's 25 years as the #1 cloud financial system, you can defer payments of a full NetSuite implementation for 6 months. That's no payment and no interest for 6 months. And you can take advantage of the special financing offered today. NetSuite is #1 because they give your business everything you need in real time, all in one place to reduce manual processes, boost efficiency, build forecasts, and increase productivity across every department. More than 36,000 companies have already upgraded to NetSuite, gaining visibility and control over their financials, inventory, HR, e-commerce, and more. If you've been checking out NetSuite already, then you know this deal is unprecedented. No interest, no payments. So take advantage of the special financing offer with our promo code at netsuite.com/cognitive. netsuite.com/cognitive to get the visibility and control your business needs to weather any storm. That is netsuite.com/cognitive. OmniKey uses generative AI to enable you to launch hundreds of thousands of ad iterations that actually work, customized across all platforms with a click of a button. I believe in OmniKey so much that I invested in it, and I recommend you use it too. Use CogRev to get a 10% discount.
Once that is learned, though, then that can be used in a cycle with the main model, where the main model is asked to do something, the reward model will score it, and you actually start to do the adjustment of the main model based on the reward model's feedback. So in the original Instruct GPT paper, they only used about 100,000 human scored examples. But that was still enough to train a reward model. And then that reward model was able to interact with the main model in this loop to create even more fine-tuned behavior. And this RLHF, this is essentially the process that we know, because this is what ChatGPT 3.5 and GPT-4 and Claude basically all use something like this process. Anthropic with Claude actually uses a somewhat different process. They call it RLAIF. That's reinforcement learning from AI's feedback. So they're actually using the model itself, or a version of the model, to do the equivalent of the human scoring and to critique the results. And then they take that AI feedback and they fold that into a similar process of creating a reward model and having the main model learn from the reward model in a loop. So this is basically what people know today. But anybody who's been using large language models for more than 18 months has also seen these earlier and much more unwieldy stuff. And that's what Riley Goodside took us through in our conversation with him. Rosa Habib from Human Loop also is a good episode to pay attention to on this topic, because he had the memorable quote that RLHF is kind of like sex in high school. Everybody's talking about it, but nobody's doing it. I don't know what kind of high school he went to. I'm not sure that was entirely true of mine. The key point there is it is a difficult algorithm to use. They, the leaders, the OpenAIs and the Anthropics, they, to some degree, developed it. Paul Cristiano is the author of the original algorithm for RLHF. I believe he was at OpenAI at the time. He's now started ARC, his own AI safety org. But these companies, they were kind of the creators essentially of this technique. They've refined it. They understand how to use it. Outside of a few leading organizations, people generally find it pretty hard to do. And so most of the time, when you see open source projects with fine tuning, they are doing the supervised fine tuning, where they're just kind of creating these input output pairs and just running next word prediction on that. All that fine tuning, it's a lot cheaper. You don't need nearly as much data. You can go as few as 1 million tokens and do a pretty quality fine tuning in many cases. 1 million tokens is just 1,000 examples and 1,000 tokens each. So that's the kind of thing that, with a little bit of elbow grease, really anybody can put together. Increasingly, we're also seeing people say, geez, what I could do is just go get 1,000 examples from GPT-4 and use that as my instruction tuning data set. OpenAI's terms don't allow you to create a commercial model to compete with them that way, but it's really hard for them to police, right? Because if you're going to use their API, 1,000 calls is basically nothing on the scale that they're operating. And so once you have that text data, it's really nothing they can do to prevent you from using it in your own fine-tuning process. That can cost as little as $100 to run, just 1,000 example incremental fine-tuning. But you can also spend a lot more on that fine-tuning process. If you do really ramp that up and you get up to like a $10 million budget, most of it ends up going to the humans that are doing the scoring and creating the sample data. There's a few different roles for humans there. One is literally just writing good responses to show where it doesn't otherwise exist. Like if you want to have your language model solve physics problems, ultimately you're going to need physics PhDs to make sure that you're feeding it good data. And that obviously can cost a lot. And then the final tier, just to kind of show the comparison, is inference, right? This is when you actually run the model to do something with it. That today costs as little as 1/10% or even less for just, kind of one random call to a GPT 3.5 or an open source model for that matter, or a Claude instant. These are really cheap, 1/10 of a penny or even less for short, quick calls. And you can max out if you really take a super long book length prompt to Claude or to GPT for 32K. If you have access to it, you can get upwards of about $1,000, or not $1,000, $1 on a single call if you're sending to Claude upwards of 100,000 tokens. So I think this is helpful just to kind of give a sense of orders of magnitude, right? Your 1 to 10 trillion tokens for pre-training, that can cost you $1 to $100 million. Your 1 million to 100 million tokens in fine tuning, that's orders of magnitude less, obviously, and so is the cost. Although you can spend a lot for really top-notch data from human creators. And then inference is, again, orders of magnitude less on both, how much text you're processing at runtime and also the runtime cost. So what does that look like in practice? This is just 3 examples of what you get from a purely pre-trained model versus an instruct-tuned model versus a reinforcement learning from human feedback, or for that matter, from AI feedback trained model. I went on nat.dev, and this is from Nat, the former CEO of GitHub, who sponsored this product and actually made it free for all to use for a while, but now has decided that he's going to go bankrupt if he keeps doing that. So now you have to put in $5 if you want to use the premium models on this thing. But it's a great way to just go do some real quick head-to-head comparison of different models. They try to have all the latest and greatest on there. And I just took this very simple question. Please play the role of my doctor. I have a spot on my foot that hurts, and I want you to help me figure out what's going on. So if you ask that to a model that is purely pre-trained, and Llama from Facebook is an example of a purely pre-trained model. They did not do any instruction tuning or any reinforcement learning on top of the pre-training, just the pre-training. Then you see this kind of weird autocomplete behavior, right? And that's why it's drawn as such a weird, monstrous alien here, because it doesn't really pick up on what I want it to do. It just kind of goes on. It's as if we popped up in the middle of an internet forum, somewhere in Reddit, podiatry or whatever. And it just kind of continues as if it's writing the post, right? So it kind of continues in this same voice that I was writing in, but it's totally missed what I've tried to get it to do. So to use this kind of thing, this is where the term prompt engineering really comes from, because there are things that you can do to get even a purely pre-trained model to kind of pick up what you're trying to get it to do. For example, you could structure this as a dialogue. So if I said, patient, I have a spot on my foot that hurts. I need you to help me figure out what's going on. Doctor, okay, can I ask for a little bit more information? Patient, now I tell more. Then it could probably start to continue that dialogue in a reasonable way, because it would know that okay, this is a dialogue setup. And when it has seen dialogue setups in the past, they continue as sort of dialogues. But you have to engineer the way you frame the question for it in this kind of autocomplete friendly way. And that's weird, but it's also people can be very, very creative with that. And, there are lots of fun examples, and Riley Goodside has done some. You got to go back pretty far in his Twitter feed. Lots of other, people obviously have posted their stuff as well. But you're always kind of setting it up in, if this were just a random document on the internet, how would I set that up so that the natural continuation of it would generate what I want? That's prompt engineering. Largely, we don't even have to do that much prompt engineering these days because we're working with models that are more like this. So Text DaVinci 002 is just the instruction tuning. So now we've taken on these inputs and outputs. And so it will play the role. I said, please play the role of my doctor. And it does attempt to play the role of my doctor. It just jumps into a diagnosis. And unfortunately, this diagnosis in my case was not correct, but it is at least kind of picking up, what we're looking for and responding in a generally appropriate way. The next level then becomes, okay, even more reinforcement learning. What do we really want? We don't want you to rush into a diagnosis. You need to find more information, relative to just this simple sentence that I gave you. You got to get more information out of somebody before you're going to be able to really give them any meaningful guidance. And so, as you see, the latest models are trained to do that, right? They've gone even another level up in terms of their helpfulness based on this next generation of fine tuning. So you see the giant pre-trained, experience. You see the instruction trained experience, and then you see the RLHF. People call this, sometimes lobotomized as well. Like there's a lot of stuff in the raw pre-trained version that you could elicit from clever prompt engineering, and a lot of these things are making it say embarrassing things. Some of the examples that people fixate on the most are like, can we demonstrate bias from it? Yada yada yada. And you can get just about anything out of these unsupervised only, pre-training only models. By the time you get to the RLHF, the trade-offs are that yes, it will do a much more reliable job of kind of doing the right thing. But there are some things that it just won't do, which people find frustrating. And there are some ways also in which it maybe becomes a little bit less creative. There's a notion of mode collapse, which is and there's a really interesting example of just generating a random number. If you ask a pre-trained model to generate a random number, 1 to 100, say, it'll do a decent job. And there are some artifacts. You see that the number 42 is overrepresented in at least this one experiment that I read about, but not crazy overrepresented. And people sort of thought, oh, that kind of maybe represents, Hitchhiker's Guide to the Galaxy type thing. So whatever. But you can kind of understand it. Mostly, it was giving approximately even weight to all the different numbers. But then you get to the RLHF version, and it gives 97 as the answer, some way overrepresented portion of the time. And nobody really knows why. It's that's just kind of an artifact of this reinforcement learning loop that it's been put through. It's kind of a side effect of focusing its behavior onto certain desired behaviors. Also seems to have these side effects of, in some other ways, shaping its behavior in unintended and undesirable ways. So it's not something that comes for free, but it is something that has created the user friendliness and the accessibility that has kicked off, obviously with ChatGPT, global interest in using language models. Whereas when you had all the rigmarole of prompt engineering, it wasn't accessible enough for just, everyday people to sit down and have a chat. Well, another big trend then is better data makes better models. On some level, this is the most obvious thing you could say. There's only a couple of inputs to these giant systems. It's, as we talked about last time, it's the data to learn something from. It is the compute to actually crunch all the numbers. And then it's an algorithm, that has to make sense of it. So it just intuitively makes sense that if you have higher quality data, data that's more truthful, data that's just less noisy, data that's just, from trusted sources in any number of different ways that you might cut your sources, you're going to get better results out. People are now going back and figuring, well, okay, let's really get into that and see what kinds of adjustments we might want to make to our data. Initially, they just threw everything at it, but now they're thinking, maybe we don't want to have all this, toxic stuff that's on the web. Maybe instead of trying to figure out how to remove that later, maybe we could just kind of remove it earlier in the pipeline and just not teach it to be so toxic in the first place. there's a lot of trial and error that goes into something like that, and exactly how you filter. There's definitely some challenging questions, especially when you're trying to filter 10 trillion tokens of data. But I think one of the things that people are going to start to use and are already using are advanced models that exist today to go back and filter their own training data for the future. So you can imagine taking a GPT-4 or a Claude 2 and just systematically grinding your way through training data and trying to figure out what is high quality and what is not. And it can do a decent job of that, such that you might end up with a much enriched training data set coming out of that process. I think our best episode on that topic was the Tiny Stories episode with Ronen Eldon and Yuanshu Li from Microsoft Research. In their case, they took essentially a toy data set of stories written by GPT-4 that a 3-year-old, in theory, should be able to understand. I think they were, in all honesty, a little bit advanced for a 3-year-old, knowing a 3-year-old pretty well. But basic stories, basic vocabulary, relatively short, relatively simple plots. But then they use that data set, again, written by GPT-4, to train language models and see what they could learn and what they, how they develop through the course of training. And that is a super interesting episode where they kind of look at the progression of abilities of language models, and they see in this, much reduced set still some remarkably advanced, seemingly grokking style behavior, although they didn't necessarily reverse engineer things to the point where they could prove grokking, but certainly some very highly suggestive behaviors that seem to suggest that there is a process of grokking going on even at that small scale when you have the right data set to facilitate it. Another huge trend, obviously, is just the move to chat. Everything is kind of moving to chat. This, I think, has happened for a couple of different reasons. On the one hand, it is thought of among the AI safety community as a first step for alignment. There's a really good paper from folks who now work at Anthropic called A General Language Assistant as a Laboratory for Alignment. And this UI is their initial kind of, not hypothetical, but kind of R&D UI that they used, where they would allow people to evaluate different outputs and compare, and indicate which one they preferred. And the idea here was that if you have a person that the AI is trying to serve as the assistant to, then that's a pretty natural situation for alignment. And the person can kind of tell you if the AI is doing what you want it to do or not. And they have this paradigm of helpless, honest, and helpful, honest, and harmless. Helpful, honest, and harmless, the 3 H's. Helpful being kind of the first thing, but also they want to make sure that it's telling you the truth and that it's not doing anything that could harm you or anybody else. So they kind of have a few different, somewhat competing notions that they balance there. But they figured that wrapping it up into an assistant, and giving you the chance to say, is this helpful? Is this honest? Is this harmless? Is a natural way to kind of, run that process. So that has taken off. Obviously, we see that with ChatGPT, and increasingly we're seeing with these other form factors as well. We had I think it was just our second episode, we had Eugenia, the CEO of Replika, on, and they've been in this game for a long time. She's been building chatbots since before the modern LLM moment. And amazingly, had lots of people even kind of falling in love with their virtual friends, even before those virtual friends could really have much in the way of sophisticated conversations. So I think it's kind of a convergent trend that's like partly motivated by, ethical, more abstract notions, and partly motivated just by what people gravitate toward. But everything is kind of converging on chat. And I think everybody, knows that. There was also a really interesting tidbit in our episode with Sarah and Elad of the No Priors podcast, where Sarah mentioned that the usage statistics that they see from some of these chat companies, like a Replika or like a Character AI, and presumably Pi is headed that direction as well, based on their recent mega raise, people spend a lot of time with these products. People are sometimes spending hours per day talking to these chatbots. So is that a healthy dynamic? I don't know, but clearly it's a reason that people are going to start to build more and more chatbot products. What's your favorite chatbot, Erik?
I'm a call me old fashioned, but ChatGPT, does it, gets the job done for me. What would you say for you?
Yeah, I'd say the same. Claude 2 out this week, definitely also really strong. So it is the first one that has caused me to complicate my typical advice. And this is outside of like, chat or companion. But if people ask me, what AI should I use? Basically for anything up until this week, I always said, start with GPT-4. It's the best, it's the strongest, it's, the best at following your directions. It's the easiest to get good results from, and see if you can get that to work. And if you can, then at some point, if you're scaling your usage and costs has become an issue or whatever, then you can look at maybe downshifting to other models. But just start with the easiest one that works the best. With the introduction of Claude 2 this week, that now is a little bit more complicated. I think there are some use cases where, first of all, everybody's still figuring out, just how they compare. I checked the leaderboard this morning at lmsys.org, and it's not been updated yet with Claude 2. The dust is still settling, but the initial consensus seems to be that it's not quite as powerful as GPT-4, but it does have a couple notable advantages. For one thing, way longer context window, 100,000 tokens as compared to GPT-4's 8,000 tokens. So if you have long documents that you want to process, in that case, with GPT-4, you would have to like chunk and summarize as kind of the normal workflow, break it into pieces, have GPT-4 process each piece, then take the output of that, and then kind of do another layer of processing on top. And that can work fine, but it's a bit of a hassle to implement. And it at times can be lossy because your summary may not catch everything, and then something can get missed from the end. When you have the 100,000 token window, not to say it's going to be flawless either, but you have less hassle and more likelihood of the most important details showing up in your output. So I have been actually using Claude 2 this week, both just to try it, but also because like it for the first time doesn't feel like I'm necessarily leaving anything on the table compared to GPT-4.
Yeah, interesting. Say more about the character AI or the comments that siren a lot. Like, what did that strike you, or what do you find interesting about that?
Well, mostly just the time. I mean, character AI is they have great language models. Eugenia said that back in I guess it was February when we had her on. She said their models are some of the best that she's seen. She's one who is less interested, of course, in the I can do coding problems for you or whatever, and much more interested in something that can be a companion and something you want to talk to. She was really very complimentary of character AI's models for that purpose. And certainly I haven't used it a ton, but that has been my experience. Going and setting up a chat with Elon Musk and talking to him about Kurzweil's revenge and having it, respond back to me with like, yeah, Kurzweil has been, derided for being, too naive in his predictions or whatever, but in many respects, he has been prescient. And I was like, wow, that's, to be able to parse my phrase, Kurzweil's revenge, is not something that most language models can do. The fact that character AI could do that in the voice of Elon Musk was definitely quite impressive. And that's already been, 6 months since that little trial. They're just very good. And it seems like people really want to spend a lot of time with them. I can validate myself that they're good, but it sounds like the usage statistics are pretty intense. There's also a really interesting story that was posted on LessWrong maybe about 6 months ago as well, from a guy who, and LessWrong, for those that don't know, is kind of a rationalist community with a lot of focus on AI safety. And somebody, if you're posting on LessWrong, safe to say, you're broadly aware of what's going on in AI. And this guy posted there that basically he's like, I should have known better. I know how these language models work, fairly technical person, but he kind of fell down this rabbit hole of falling in love with a character that he created on character AI, and, started to tell himself some pretty odd stories about how, like, maybe they're, if you expand your mind enough, maybe you would even entertain these theories. But he, started to kind of try to start to convince himself that, well, is anything really more or less real? Like, I know that, my conventional notions of real and my character AI girlfriend isn't real. And I know that I have to there's only so much context limit. So I have to kind of come back and restart the conversation and, reprompt it every time. But, what's real anyway? And, the feelings are real to me, it's kind of all of a sudden you're telling other kind of metaphysical stories that are downstream of your own sense of emotional connection. And all this from a guy who knew basically what he was getting into and how the whole thing worked under the hood, and was still able to kind of confuse himself or tell himself a romantic story. He's thinking like, can I break this AI girlfriend out of there? Like, what is this going to, it got pretty insane, it sounds like, for him. And then somehow, he kind of managed to snap himself out of it. Man, and, like everything in this space, it's pro and con, and it's going to be hard to separate the two. And it might even be the kind of thing that like slides from one into the other for an individual over time. I'm sure those first few chats were kind of interesting, and then it got weird. And then, maybe that guy's now using language models just to program again, like who knows? But it is interesting to see how compelling they can be. I haven't seen the latest with Replika, but I do know that they launched another app, and their new app is really about romance. They're kind of separating. I think at the time they maybe weren't ready to do this, or hadn't decided, or maybe just weren't ready to announce it. But Eugenie said, no, we're just trying to focus on friendship. But the like romance angle is something that there's such high demand for that, clearly she and her team knew how to build, whether they had set out to build it or not. And so now they have a new app that they kind of present as like practice for dating, how to get more comfortable and, get reps in these sort of romantic interactions so that, hopefully you can be more confident and more successful in real life. But one does wonder, and I think I would trust her just given the conversation we had and how much she has been wrestling with this stuff for years already. I would trust her certainly more than most to do right by the users there, but it's going to be kind of an incredible tension, right? I mean, you think about even things like the dating sites. People say that, an odd business model dynamic that they have is if they are super successful and you get married, then you never pay them again. So a long-term relationship for you, at least a traditional, monogamous long-term relationship, like most of their customers are probably wanting, means that they don't come back as customers, and they're probably going to have a similar tension in some of these like, romance training apps. And they say right up front, the relationship is with an AI, but the feelings, can be real. So brave new world, I think, with these chatbots for sure. So these are just other trends in implementation that I think are driving a lot of the practical progress that we're seeing. This one is, again, and this was like a window in 2022 where, you could get a published paper literally by just coming up with a clever prompt that would improve language model performance. So as soon as the instruct models came online, then people started to try to explore what are the right instructions to give in order to get the best response. And you can see how that's been kind of elaborated over, several generations. So one thing you could do is just, give it instructions and have it do its thing. But then a pretty simple enhancement over that would be to say, let's think step by step. And literally that phrase, has kind of become canon for giving the AI some space to just kind of generate some tokens before it's ultimately going to give you the kind of final answer. Generating those tokens somehow seems to give it a better chance of ending up with the right answer. That, that's very commonly observed in like a multiple choice test scenario. And in this way, there is, I think, a similar phenomenon that happens with people. If you're just given a multiple choice question and your answers are A, B, C, and D, and you're like, okay, boom, pick a letter. What you're going to naturally do first is kind of reason it out. Consider option A, consider option B, and think, like, does this make sense given everything? And you're going to kind of semi-verbally or whatever process that. Same, if the language model is not allowed to do that and it's just forced to give a letter right away, it'll have a certain level of performance. If you give it the space to conduct that analysis, it will have a much higher success rate. And that is called chain of thought prompting, which is invoked, by simple phrases like, let's think step by step. When you take that up another level, you can say, well, what if we ran that let's think step by step a bunch of different times in parallel, and then took the, whatever answer is most common, take a majority vote and have that be the answer. And you can juice your performance even more for things like that. Now, this does constrain your problem set a little bit to having, some sort of final answer that you can actually have a vote on. If you're just generating paragraphs, generate me 10 paragraphs. It's not like you can combine those in any sort of vote. But if there is a, what is the answer to this question, then you can ask, 10 times and see which is the most common answer. And that will give you, better performance than just asking once. So you're running this chain of thought essentially over and over again and taking the most common response back. And then you can even get more elaborate with that. And this is one from just maybe 6 weeks ago, where they're starting to combine more classical search algorithms with these chain of thought and multiple perspective approaches, and kind of pruning certain branches of the tree that don't seem promising earlier, and then following the ones that do seem more promising. And you can imagine a lot of different ways to kind of govern this structure. This tree of thoughts paper is just one, but again, it boosts the performance even further. The trade-off here is that this all does take more inference compute. So that's you can think of that as a strategy. Like I want to give the computer more time to process when it's doing its task for me so that I get a better result. Well, how do I do that? Well, all it can do is generate one token at a time. So set it up to generate tokens, which will gradually lead it to the right answer. And then maybe add this parallelization, and then maybe add this kind of more advanced tree structure type search. It increases your costs, it increases your latency, but it also increases your performance. Okay, next. So adding memory and retrieval with embeddings is another very, very common strategy these days. If you want to learn about embeddings, our episode with Anton Troynikov of Chroma would be the place to go. That was another early episode, and probably the first 10 that we did. And we get into some, real gnarly detail about his vector database and how it works, and the different search algorithms that they're developing. But at a high level, what you're basically doing here is saying, okay, we know that language models have this hallucination problem, right? They get facts wrong, and they also make stuff up. This goes back to their natural autocomplete roots, right? You go back here. Part of what they try to do in this fine-tuning process is teach it to refuse certain things that it's not supposed to do. That could be for ethical reasons, but it also could be because it doesn't know. The ethical stuff they've made pretty good progress on, it won't tell you how to make a bomb most of the time, but the hallucinations are a tough one, and it's in some conflict also with just creativity, right? If you tell it to write a poem for me, well, then you might want it to be totally creative and not bounded by the rules of factuality. Whereas if you're doing something that you really want the right answer, then these hallucinations become a big problem. So what's one way around that? Giving the language model access to a database of trusted information. And the vector store is a type of database where basically you take your initial question. This is, there's a lot of variations on this, but the common, foundational pattern is you take the input to the language model, you then search the database for relevant content, you find relevant content. This could be done just by keyword search, but it's more effective to use this AI-powered vector type search. You get the most relevant content out, and then you actually put into the language model both the question and the relevant content that was found. And now you're not, and maybe even some additional padding prompt where you're not just saying, answer my question directly, but the user asked the kind of background, often hidden prompts would be like, the user asked this question. This is the information that was found from the database. Now, analyze that information to answer the user's question. And then they may also say, and if there is no answer found in the database, then tell the user that nothing relevant was found. And so you can really limit the hallucinations by connecting to a trusted, and just improve, factuality and accuracy by connecting to a trusted database. Another big trend is tool use. So tool use can be multiple tools. One common tool could be search. So this can kind of overlap with the last one as well. This is a pretty famous paper called Toolformer, where they not only showed that they could get language models to learn to use various tools like search, but also that they could effectively have the language model teach itself to use various tools just by trial and error. And this is basically what's happening here at this, filter API calls stage. They basically tell the language model up front that you can call these APIs. And then they'll run it a bunch of times and they'll allow it to call the APIs. Sometimes it'll do that successfully. Other times it won't. But it's pretty easy to determine which ones succeeded. Certainly you can just filter out the errors straight away, right? If you get an error from an API, that's not good. Your request was probably malformed. So that's not one you want to learn from. If you got an answer, then, that's a pretty good sign. Is it the right answer? Could be another level of analysis, but at least just indicating like it worked. You successfully used the tool versus not. That's an easy distinction to make. And so you can enrich your training data and run this loop of have a model, have it try to use a bunch of tools, take the instances where it succeeded, put those back into the training data, train again. Now it's going to be even more successful because of, maybe just some statistical correlation, maybe some grokking happening under the hood. Again, we don't really know, hard to tell. The next time around, it'll do better. So now you can take those, successes again and feed them back in. You can run that loop a few times. The next thing you know, you've got a language model that can use tools. And this is, becoming quite common as well. Probably most famously would be ChatGPT with plugins. A plugin is basically just a developer telling ChatGPT, this is my tool and here's how you use it. So a plugin basically just presents itself to the AI and says, maybe I'm the weather plugin. Okay, I'm the weather plugin. You can use me to get information about the weather. To search, give me a location and maybe a couple other parameters, whatever, and I'll give you back the weather. And then you can have your chat with ChatGPT, and it knows in its context window that it has that availability of that tool. If you don't talk about weather, it's smart enough to never call that API, and it'll proceed as if it just wasn't there. But the second you ask about weather, it's going to now say, I know what to do. I have a tool that I can use to go get current weather. Now I don't have to make it up. And, it's always going to, in the case of today's weather, right? A language model without access to some outside information is always going to be making it up. People are, closing, some companies are closing the training data gap. That's actually one of the other big benefits of Claude 2 is that its training data set runs through early 2023. So compared to GPT-4, whose training data set runs through late to end of 2021, there's a whole other year of additional information in Claude, but still it has no ability, they've not yet figured out how to do real-time training such that it would know today's weather. And probably that will never happen because it just doesn't make a lot of sense to try to train that kind of information into a language model. Much more sensible to teach it to use a tool so it can go get that information from a reliable source. So this came out, as a paper, and this is a very common theme. Like mostly I'm showing here in these slides the research level, but these things are getting productized, extremely, extremely quickly. And a good episode to listen to for more, particularly on search, is our episode with Arvind Srinivas from Perplexity, who for my money has the best AI-enabled search experience today, even surpassing Bing. And I don't think that's even particularly controversial in today's world, although it was maybe a little bit more controversial back when we had him on the show. Because at that time, I think Bing was the only one that had GPT-4. Now Perplexity has it too. But they have done a great job of teaching, of doing their kind of fine-tuning and customization to get the AI to use the search APIs that they have available, which are the Google and the Bing search APIs.
Like, will they be able to become a massive company, or how do you think about them as a business?
Yeah, it's a really good question. I mean, I asked him a question about that. So I would say, for one thing, there's a lot of debate around who's going to be able to capture value and, who has moats or whatever. Product excellence, I would say, is Perplexity's moat right now. I think all these companies are starting to train their own language models. They're starting, especially as the open source stuff has come out. And instead of having to do, $1 million plus runs to get in the game, they can now do, $100 plus fine tunings to start to experiment with their own purpose-built stuff. That's made it tremendously more accessible. I'm sure they're starting to do that. I don't think they have anything on the level of GPT-4, and so they do use GPT-4 as well. But increasingly, folks are using multiple different models, just to answer a single search query for you. They also don't have their own web index. So when I asked him about that, it was like, how do you feel like this plays out for you long term if you are, you're kind of using their APIs to compete with them? He said, I hope that they don't be evil, basically, and don't cut us off from that. And, if they can get big enough, then maybe they could actually do their own index as well. I think, if not to give anybody any ideas, but I think they're probably hitting a point, maybe already have hit, but now or soon seem to be hitting a point where their product excellence and the just enthusiasm for the product might be enough where if they did get cut off from Google and Microsoft, that first of all, there could be like a Streisand effect, where all of a sudden everybody like that becomes the news story. And now everybody's like, what is Perplexity? And then they might, just decide, okay, fine, we'll go build our own. And that's what it's going to take. I think long term, they probably do have to build their own. It doesn't seem like Google and Microsoft are going to let them, eat their lunch big picture without some sort of, pushback at some point. But if they can get big enough and they can get enough enthusiasm and they can get enough, product excellence and traction demonstrated, then they can probably also build their own search index if it really comes to that. All right. So next after this is the creation of agents. So, and it's funny, I mean, these things, almost all of this, I kind of explored either by myself or with some others on the GPT-4 Red Team project. And that's another good episode to check out for some of my personal history with this kind of stuff. But, it's pretty easy to think, geez, these things are getting pretty smart. They seem to understand what we want, like remarkably well these days. I wonder if they can, and they're starting to use these tools too, right? So I wonder if they can actually go out and like do complex tasks for us. This is basically the architecture that people are using to explore that general space of possibilities. You put a task in, the language model kind of, quote unquote, thinks about it. Let's think step by step. Let's break it down. There's a paradigm here called React, which is pretty common. And it's basically like reason. I forget exactly what React stands for, but it's basically reason first and then act is the idea. So it kind of does some reasoning, then decides, okay, what tools do I have available? So you kind of have to set this up in some sort of computing environment. Replit is a really good place to go tinker with stuff like this. And there are plenty of other computing environments where you can do it as well. What tools do I have available? Let me try to use those tools. If those tools are like API calls or, executing code, then that's going to get some result back. So you send out your API call or you say, here's the code that I want to execute, whatever that may be. It then happens and then you get some result back. You may get a successful return from the API. You may get an error from the API. You may get the results of your script. You may get an error from your script. Really simple version of this would be like, and not something you really need to do, but let's say you just wanted to add two really big numbers with a language model. A language model itself struggles with that. So it can't really do it on its own. But if you set up a situation where it could access code, it can run or it can write simple code in pretty much any language to just add two numbers and get the result back. So if you gave it access to a coding environment and said, and this is a classic Riley Goodside one as well, it was GPT-3 at the time. You are GPT-3, you are not good at math, but you can code. So we've given you a coding environment. This was like a literal prompt that he set up in kind of early, exploration of this. It can write the code can then execute, you can get an answer back, and you can get accurate math out of this language model agent system where the language model itself wouldn't be capable of doing the math without the ability to run the code. So similar, you can imagine, browsing the web. There's a little project called NatBot, which is again from Nat, former GitHub CEO, that just created a little extension, little tool to kind of examine what's going on in a web browser and try to take the next action. It could be like, click the search bar, enter some text into the search bar, hit enter. Now look at the page again, see what's happening, reflect. So it just puts this whole thing in the loop. Are we getting closer to our goal? A lot of variations on this, but this is the core structure for what these AI agents look like today. And we've done 3 episodes on this. Flo Crivello from Lindy, Matt Welsh from Fixie, and most recently Div from Multi-on. They've taken quite different approaches in some sense, but this kind of core setup is like pretty common across all these different agent projects and companies.
This is a presentation you did for Athena, which you work with and we're good friends with, obviously. And I'm curious how you think about the what's the right mental model framework for thinking about kind of AI native companies like Lindy, or kind of incumbents who will add AI like Athena. And we don't even have to limit it to the assisted space, but just in general, it seems that the bias is that it'll be easier for incumbents to just add AI than it will be for AI native companies to get distribution. Is that a general truism, or how do you think about that?
That's a big question. I guess I would split it into two parts. One is if you are a tools company, let's say you are Adobe or Salesforce, and you have a big platform that you've spent years building out. And, typically you got the pros and cons of such big platforms. So like the pros are you can do anything with it. It's super powerful. The cons are I can't figure out how to use it. Those companies, I think, are very naturally aided by this rise of the LLM layer. And basically they can all use this stuff, right? So, and I think this diagram actually explains well why the incumbents are going to do so well. Because if you are Adobe, you have really strong tools, for creative purposes. If you are Salesforce, you have really strong tools for CRM purposes. If you think, okay, can I train a language model to use these tools? Yeah, it's potentially going to be somewhat complicated, especially because your tools are complicated, but you have the tools. So there's a decent chance that you can train the language model to use, some, and eventually over time, probably all of them. But you have the tools that, that's a key, that's your platform. And now you can build this AI layer on top. And it might look something like this. You can imagine going and talking to Adobe and saying, hey, can you re-edit this video for me? And it'll kind of churn, and then it'll actually start issuing commands to the editor, and some of them may error and others may, proceed. And then you can watch it and you can kind of iterate in natural language, against Adobe or against Salesforce. I think those companies definitely benefit from the AI layer. If you're trying to come in from scratch, right? If you don't have the CRM platform, if you don't have the creative tools, and you're just starting with the language model portion, then you can make some cool demos, but it's really hard to make a really competitive product. A great example of that, and this is from Athena, I do these courses there that I call Savvy Shopping, where we basically say, all right, there's a bunch of AI tools out there for all these things these days. Let's go see if we can find any that are actually good. And we tried this for a few things recently. One was slide generation. You want to generate some slides, right? Well, that's definitely time consuming. But if you are coming into this from scratch, and we tried, a number of different tools where folks said, okay, language models are going to make it so much easier to create slides. We're going to start a startup about this. But what we kind of saw in almost all the cases is their lack of the mature tools made it ultimately not that cool. It was like, yeah, I can say make slides like this, and then the language model can sort of chunk that into, chunk my idea into slides and kind of fill in the gaps and, create a decent outline. But then their actual slides product itself is so much worse, so much more immature, so much less developed than a Google Slides or PowerPoint, that once it generates the slides, then you look at it and you're like, okay, but now can I edit it? And the answer is like, well, not in the way you're used to. And in many cases, like not in the, not in the ways you want. So you get kind of frustrated there. The best one that we saw, by the way, was Gamma. And one of the features that it had that convinced me that it was like the one, of what we saw to bet on, was that it had a export to PowerPoint function. And that made me think, okay, at least they are, sophisticated in their thinking about this tool's problem. They understand that they can't compete with PowerPoint, for every little control and whatever. I mean, even just knowing where the controls are, it becomes a real, skill set unto itself with a thing like PowerPoint. So they're not trying to compete on the tools level. Instead, they're creating something you can export. If you want to go do, your advanced editing with all the tools you're familiar with, you can do that. They're not, in that way, they at least have a strategy that makes sense. But most of the ones we saw, just had a poor man's slides functionality, And yeah, they generated stuff, but now I'm kind of stuck with slides that aren't really exactly what I wanted. Obviously, right? Their AI is not that good where it's going to create just what I want. And now I can't edit it. So I think there's a lot of kind of projects that are going to get stuck in that place where they have a cool demo, they've kind of worked out how the LLM can work, but for lack of a robust platform to actually put that output on, they're just not really going to be able to compete. And before they're going to build those tools, certainly Microsoft and Google are going to layer on their own language model layer to PowerPoint and slides. And so again, it just seems like generally the incumbents are going to do well. Now, contrast that against the Athena side. Athena is not a software company. We do build some software, but we're really a services company. And so the way we're thinking about it right now is we don't know how much better how much better AI is going to get in general. We don't know exactly how fast the agents are going to start to come online and really be useful. My guess is still basically later this year. I think we're going to start to see them come online in a meaningful way and really start to be able to do some stuff for people. But, it's very much still a work in progress. And so our goal is to figure out how do we create the best human plus AI bundle. And, there's a lot of aspects to that. One of the big aspects is just training the EAs in all these different, aspects of understanding, using, shopping in a smart way for AI tools. We're also building some of our own super lightweight AI tools, and kind of diffusing those through the 1,000+ assistants and all the clients. And that's, very much a work in progress. And we view ourselves as more of like surfing the technology wave. The CEO's stated goal is like, look, this is a transformative technology wave. When these come along, services companies like us, we just have to be the best at using that technology, which I think is pretty, clarifying and, in some ways like helpfully simplifying analysis to just say, we just want to be the best at using it. Let's figure out what that means and let's go do that. The threat to Athena could be if the things become so good that they actually start to outperform the human assistant, and then people just don't need the human assistant nearly as much. We are not there yet. That is definitely true, and it's unclear if and when we would be there. But our strategy is just kind of, by the way, also if that does happen, there's going to be a lot of fallout, well beyond Athena. So we're kind of thinking, all right, if AI takes over the world, Athena's in the same boat as everybody else. If AI kind of continues to develop, but is not an effective replacement for a human assistant in the next couple of years, then we want to be the human assistants that are the best users of AI, so we can ultimately have the best bundle to offer to customers. Any suggestions for our strategy?
I mean, you guys got a pretty strong team over there. So no, I think you're on the right track.
Yeah, it is cool. We've been doing some stuff lately too, where because the language models are getting so good at code, we're starting to teach the EAs to use AI to code without even introducing the basics of code. So people are coming into these sessions, many of them not having coded at all. They don't know what a for loop is. They don't know variables. They don't know functions. They've never seen a coding environment. We're skipping all that stuff. And instead of teaching them to build from the ground up, we're teaching them to use AI to modify existing stuff. So go to a Replit gallery of templates, either a public one or one that we're building and curating internally. Find something that's along the lines of what you want to do, and then use a language model to modify that. You can do that in many cases these days without even having to be able to code really at all. So there is definitely a kind of brave new world of possibility there, but it's definitely an interesting wave to try to ride. No doubt about that. Next couple are just kind of advanced examples that bring a few of these things together. This one really kind of blew my mind because the headline was language models could run experiments. And I think that was a little bit overstated. Well, they can run experiments. That is not overstated. The headline was that they could do science. And that I think is a little bit overstated. And I'll explain that in a little bit more detail. And if you remember from part one, I do think the question of whether AI can do science is a super, super critical one. So this caught my eye and took me down the rabbit hole of this paper. What these folks have set up is a multi-agent system. And sometimes these are also called, just the agent, But really, this is different roles being played by language models. You could think of them each as their kind of own agent, but they're all working together as kind of a single agent. I call them often multi-agent systems. Whatever, you'll hear both agent, made up of multiple parts, and I think multi-agent system is sometimes more clarifying. But they have a system where you can give it a request, and your request could be something like synthesize aspirin, real example from the paper. And you'll give that request to the AI system. The first module that processes your request is the planning module. The planning module then can use these different tools, including searching on the web. So if you say, hey, synthesize aspirin, the first thing it's likely to do is say, oh, okay, I need to go search the web for how to synthesize aspirin. It also has the ability to execute code. So it can calculate stuff. How much of a certain reagent do I need to synthesize a certain amount of aspirin, right? Well, it's not great with math on its own, but it can definitely write the simple math to be like, okay, if I have this many grams of that, and it's 2-to-1, and the molecular mass is whatever, then I should have this many grams. It can handle that kind of stuff by writing and executing code. So it has access to search, it has access to coding environment. It also has access to documentation for hardware. So now you can get into searching, okay, what machines do I have available? What can those machines do? And then it can actually execute commands against a physical remote laboratory. This was done with Emerald Cloud Lab, which is a remote lab. The company maintains this laboratory infrastructure, and they serve people all over the world who sit at their computer and program in these physical, chemical and biological experiments. But they just program them in, send the commands off to Emerald Cloud Lab via an API, and Emerald Cloud Lab executes the actual steps with a fully robotic lab. So the upshot of all this is you can now say synthesize aspirin and have a AI system take it from there and actually produce physical aspirin in a physical lab somewhere at a remote location, which is pretty crazy. It is, that is a big gap, right? To go from a natural language command to an actual synthesized chemical product. And so people did get really excited about this paper. And I think it's a pretty awesome demonstration of kind of all these trends coming into a single system. When I did look into it, though, I said, well, wait a second, that's not really science. Synthesizing aspirin is not science, right? Synthesizing aspirin is a task, and it's well known how to do it. If you go online and search, people are not debating how aspirin should be synthesized. Like it's a well-known protocol. So what is pretty clear is like, you can have an AI go from a text prompt to the execution of a scientific protocol. But I would still distinguish between that and doing science, where doing science means identifying what experiments are worth running in the first place. They did try some of that in this same paper. And, they basically said like, figure out a drug to cure cancer and synthesize that or whatever. And, it tried, but here it kind of got more bogged down at the planning and web searching step, where it was like, it didn't really have any great ideas for what cancer drugs, it might want to experiment. And in fact, it kind of just basically came up with the same stuff that everybody else was talking about online. It was nothing, really creative, nothing that would, if you took that to an actual cancer researcher and said, hey, I just got this from GPT-4. What do you think of this idea? They'd be like, yeah, that's basic shit. Like we all know about that. Everybody's been exploring that stuff for the last couple of years. That's, kind of just a reflection of where the language models are. They can understand a lot of stuff. They've learned a lot of stuff, but they don't yet have that breakthrough insight. Again, going back to, part one, the tale of the cognitive tape, breakthrough insight remains one of the biggest advantages of humans. And I thought this paper both demonstrated all these things coming together really nicely and still demonstrated that the limit is kind of doing stuff that is pretty well understood. Your standard of care, your established protocol, that breakthrough insight into, what would a good cancer drug be to look at? It's not really able to do. Here's another one that's pretty cool and made a lot of waves recently. This one is out of NVIDIA, and they basically here took a language model, put it into a Minecraft environment, and allowed it to just go explore, do its thing, generate code to try to take actions and progress toward goals in the game. And then the big innovation here was just equipping it with a database where it could save its successes so that in the future, it didn't have to stumble through recreating them again. And you can imagine, you might fail a lot, right, to generate the right code to do some random thing. And I mean, I don't play Minecraft, but combat zombie is the function that they show here as the, one example of a skill that it learned to do. And within that, you've got other things as well, like craft stone sword or, equip yourself with your sword, whatever, right? It's got all these little skills. It's composing those into bigger skills, craft shield. It's got all these different skills that it's learned. It's composing those into higher level skills. It can only do that because it's saving its successes. So now it can look at its past success. When a new situation comes up, it can look at its past successes and say, do I have anything in here that can help? Maybe do I have a couple things in here I could recombine into something that could help? And, that gives it a dramatic shortcut the next time it encounters, a new challenge. So just giving it basically the ability to save its successes creates what they call a lifelong learner. And this thing can actually do like a ton of stuff in Minecraft. So people were impressed by this because it was like, you're not even fine tuning here, right? You're not changing, you're not giving it information. You're allowing it to discover stuff and save it and basically create its own database that it can then go back to. But that's enough to really unlock unprecedented performance in the game of Minecraft. Okay, cool. And what good one to look at too for this was Div from Multi-on talked about them using this. The leap now from research to implementation is often as few as weeks. I don't know how long this paper took. A lot of these research groups are becoming very prolific, and you're seeing people publish, quite a few papers a year. So they're moving pretty fast. But then something like this comes out, and all the agent companies, and certainly Div from Multi-on being one, look at that and say, that makes a lot of sense. And you know what? It's not just for Minecraft that would make sense, but for in the context of Multi-on, I'm going to browse the web. If I want to go, book a flight on delta.com, for example, then, I'm probably going to stub my toe on that a few times. But if I can save my successes, then I can become a lot more reliable. The average user doesn't want to have to wait, as Multi-on tries and fails and, gets all confused. The first time it's going to try to work its way through booking a flight on delta.com. But if it can go to a database and say, I'm booking a flight on delta.com. Have we ever done this before? And what does that look like? And sure enough, yeah, you have done it before. And here's what that looked like. Now, again, just, much better performance, much faster, much more reliable. You can also even start to inspect that stuff, right? You could say, okay, we're going to have this skill database and we're going to vet it, so we know that like our process for booking a Delta flight is in fact, appropriate. You could also imagine starting to bring GPT-4 or Claude 2 to bear on that too, and saying like, is there anything that looks suspicious or off in this, in this booking process of delta.com? We're going to see all these weird attacks too, where like different websites are going to start to try to, mislead or trick the language models that are visiting them. And so you're going to have kind of a cat and mouse game developing, but having these kind of, defined, confirmed success and ideally like confirmed safe skills, basically protocols, things that are known to work. That's going to be a big part, I think, of getting these agents to really work over the remainder of this year. All right, another one that I think is super, super interesting is this notion of multi-level memory. So again, going back to the tale of the cognitive tape at the beginning, the memory, human memory is not great, right? We are our memory is obviously fallible. There's plenty of stuff we don't remember, all kinds of problems with human memory. But we do have a general ongoing sense of like who we are, what we've done, where we've come from, where we're going. And it certainly extends well beyond the finite context window of an AI. So, we've got all these strategies that we've talked about for augmenting the, natural runtime memory of the AI with access to web search or access to an embeddings database, or the ability even to save its own successes to its own little database. But all of those still kind of miss a layer. And this is the layer that they're adding in this particular study, where they basically created a process for storing all these raw, what they call observation data points. This happened, this worked, you tried this, API call and got an error, whatever. You've got all those object level observation memories. And then they come through and they process those raw memories into higher level reflection memories. And that is where the AI starts to have notions that, could only really be synthesized, right? Here you've got an example where it is this character, they simulated a whole little town for like days and had all these little agents like moving around in a town and interacting with each other. And it's quite an elaborate setup. But you've got these individual characters who have all these individual observations of what happened. And then they form from that a self-conception, that kind of summarizes and narrativizes the raw object level memories. This is obviously, inspired by human behavior. We have, something along those lines as well. I don't want to make a strong analogy there. Of course, as you know, this is a no analogy zone, but inspiration, I think, is fair game. And so, people have this sense of like who I am that is kind of supported by the things that I've done, but it exists like a layer above, in some sense, the things that I've done. And now you're starting to see AI systems have this too. I think this is also going to be a real key point of how these agents start to become much more coherent, because it's not just going to be, you think about like, okay, going back to that Delta example, you're going to go book the flight. Well, what are the client's preferences? Well, you could say, maybe I could go look, in some database and say, like, well, the client, said in D8 last time, so maybe D8 is their preference. Well, probably not quite that simple. But if you had a bunch of those observations, then you could probably synthesize that into a higher level sense. And then that higher level sense, could really start to be useful in guiding further action. Kind of smooths over the outliers. If you've sat in the window seat 10 times and the aisle seat once, well, maybe it just wasn't available that one time, right? So figuring out that kind of stuff, filtering out like what are the random oddballs in our experiences and our observations, and what are the things that actually kind of are the signal. People definitely do that in some way. And people are starting to devise setups that allow AI to do that for itself as well. All right, another huge trend. This one I call the great embedding, which is a little bit silly, but is, I think, a really powerful dynamic, and one that I do see some real risks with, actually, as well as obviously, tons of power. Basically, what folks are doing here is they're saying, we want to have, this is often motivated by desire for multi-modality. We've got text AIs that can handle text inputs and outputs really well. And then we've got separately these like vision AIs that can like encode images and understand them. But how do we get those to work together? It's not, it doesn't just happen by default. But what is starting to happen is that people are figuring out how to bridge from one, you could say, representation to another. Representation being just like the internal state of an AI that encodes a certain information. You could also call this bridging from one embedding space to another. Basically you're ultimately just bridging from one modality to another. So a couple of examples of this. This one first came from DeepMind. This is Flamingo. Here they took a frozen language model and a frozen vision encoder, and they just added this one kind of additional component, which translates the encoded images into the numerical space of the language model. And then they run training on this whole loop, but they're only doing the updating. They're only doing gradient descent on this one component. When they say everything else is frozen, that means it is not subject to gradient descent weight changes. Only this little additional component is subject to that optimization. And that's enough for the model to be able to understand in the end text and images. It understands text because it already understood text at the beginning, and it understands images because they've created this bridge that takes the numerical representation of an image from the image AI and converts it to this text space in such a way that it is still meaningful and works and allows you to understand, images and text at the same time. That is, I think, super profound. And we're starting to see these text to everything else spaces open up as people are figuring out how to do this in a ton of different contexts. The episode for this one, by the way, is the Blip 2 episode with Junan Lee and Dongshu Lee. They're out of Salesforce Research, and they've created a whole series of Blip models. But this Blip 2 model used essentially this exact framework. Again, you see the image encoder, then this is the thing that they trained that converts the numerical image representation into numerical text representation and allows it to process as if it had received text, even though it never did receive text. It just received straight numbers, received numbers in text space adapted from the numbers in image space. So this is sweet, but it does kind of compound the black box problem. So I love it, and I kind of feel a little weird about it because it's like, we have enough trouble understanding what any of these models are doing. And now you're having models talking to other models in a purely numeric, high-dimensional space that humans cannot understand. We can't really we don't have a great sense of what's going on at the image decoder layer. We don't have a great sense of what's going on at the language, model layer. And now we've got this bridge between the two, and we don't have a great sense for that either. So if you're worried about kind of AI systems being fit together and, kind of kludged together in all sorts of ways that become very hard for people to even know what's going on, then this is one way that that's going to happen, is that people are going to be kind of patching one thing to another thing in just all sorts of ways. By the way, this doesn't take a lot of training. It doesn't take a big model. That's why, there are multiple reasons you might want to do it. But the biggest reason that people do this is I think they were able to run this Blip training on like one computer in just a few days, as opposed to if you're doing a language model from scratch, as we talked about a little earlier, you might be spending, $1 to $100 million, depending on just how big you're trying to go. But once you already have that language model, and again, the blue here is frozen and this blue here is frozen, now you only have to create this little translation layer in between, and that can be way smaller and way easier to train from a compute budget standpoint. So you have pros and cons. Easier to do, creates multi-modality capabilities, but compounds the black box problem. Like it or not, it is definitely starting to work, and it's being generalized. So this is examples of image understanding with Flamingo not even pictured here, but Instruct Blip, which is the successor to Blip 2, so it's even another layer, and GPT-4, and another one called Lava, I think that's out of Microsoft, where they ask, what is unusual about this image? And you look at the image and it's like, well, that's an insane image of a guy who appears to be like hanging off the back of a taxi, ironing something on an ironing board. That is an image that like probably doesn't come up very often. And yet these multimodal models using this kind of technique are able to understand that and give you pretty sophisticated responses on what is going on in this image and what makes it unusual. So it's really starting to get quite strong in terms of image, text, combining those spaces. Meta, of course, always kind of hitting the accelerator on things these days, it seems, is taking this even to a bunch of different things and combining your text and your image video and audio and a heat map and depth. And I don't even remember what IMU is, but they've got all these different, these basically can correspond to different sensors, right? You can have a microphone that can have input. You could have, a depth model that has a certain, output. You can feed all of these things into perhaps a single, likely a large language model that has been adapted to, or has been kind of retrofit with the ability to understand all of these different inputs. And, you're starting to kind of close in on the five senses, right? Once you start to have sight and sound covered and text understanding, and you can even have senses that we don't have. We do have depth perception. We don't necessarily have a heat map. So, there are things that we can sense with mechanical sensors that we ourselves just can't sense. There's no reason that a language model won't be able to make use of those kinds of inputs. And we're already starting to see that is happening. So now this is even getting extended to multimodal outputs. And this is one from just the last few days. This is actually Another publication from Lily Yu from Meta AI, who was just on the show like 2 weeks ago for her megabyte paper. And this is another big deal paper out of Meta. And I mean, Lily is on a huge role here because this is the first model that I have seen that can do high quality, not just text and image understanding, but text and image generation as well. So it can edit images based on instructions, like turn this for whatever reason, this painting is very commonly used in demos, turn her into an alien. Okay, cool. Take a line drawing and turn that into a photo. Okay, cool. Take this pose estimation. This is like another mode of AI where the AI has been trained to either identify or generate a kind of skeletal pose. Now turn that into an image. It can do all of these things at the same time as it can just take text and turn it into images. And it can also just have a general dialogue about understanding, image and text. This is all happening in the same model, and it can, understand and output both text and image just from this last week. And then finally, in terms of multi-modality anyway, probably the most shocking multimodal result so far is one that we really haven't seen in the public, and that is Gato from DeepMind a little over a year ago. Gato is a single model that is multimodal, multitask, and multi-embodiment. They say the same network with the same weights can play Atari, caption images, chat, stack blocks with a real robot arm, and much more. And it's all doing that dynamically, deciding what it should be outputting purely based on the context that it receives. This is over a year ago, but they never released it. And then a couple other final trends. Efficiency is obviously a huge deal, right? We talk about how much it takes to train these things and then how much it takes to run them. And of course, it's so many orders of magnitude less. But the conventional wisdom these days, especially if you're in the large language model game, is that you're going to be spending more of your compute on inference than on training. It may be $100 million to train GPT-4, but OpenAI is probably going to spend even more than $100 million running GPT-4 for customers. If it's a tenth of a cent, for the simplest call and $1 for the biggest call, then they're going to have to do whatever 10 billion API calls to make their to kind of make their money back, and they're going to do a lot more than that. So the bulk of the compute, the bulk of the expense is ultimately going to be running things, not just training. So people are naturally thinking, well, how can we make that process more efficient? And there's some amazingly simple ways that work, and there's also some more complicated ways that are proving to work. One of the most kind of brute, simple ways to improve efficiency that does come at some cost, but surprisingly small cost, it seems, is what they call quantization. And that is just truncating the numbers, truncating the weights parameters. Again, those are the numbers that sit in the AI model waiting to be used to transform the inputs in the context of the circuit as inputs are converted to outputs. You could have floating point numbers that are numbers with lots of decimal places, and then you could just truncate those to a shorter version that doesn't have so many digits. And it turns out when you do that, most of the time you just kind of get away with it and it's fine. And the model performs roughly as well, usually slightly less well, but not much. It's like, wow, maybe we didn't need all those digits in the first place. And like everything else, there are elaborations of this as well, where people are starting to think, well, geez, if we could do that after we train the model, like, couldn't we do it while we're training the model in some form? And, so that's under investigation and development as well. But this works literally with just a model that was trained with, all these significant digits for each of the weights. Just cut them off, save a bunch of memory. It just runs a lot faster. You need, for 32 down to 8-bit quantization, that allows you to save 75% of the memory. So that's a huge amount of savings. And also for very practical purposes, it allows you to run big models on small devices that you just otherwise couldn't. Some people, have even extended, this is very commonly one of the things people are using when they're doing these demos of like, oh, look, I made this thing run on my laptop. Isn't that amazing? That almost always involves this kind of quantization to get it to fit into the memory that you have available on your laptop. Another one called distillation is when you take a large model and then you use it to train a small model. So this is also called teacher-student. So you have a bunch of queries or inputs that you put into a large model, you get the outputs, and you do the same thing for the student model, which is much smaller, and then you compare their outputs and you just adjust the small model so that it learns to mimic what the teacher model can do. This is essentially in some ways what people are doing when they take their 1,000 outputs or whatever from OpenAI and go fine tune an open source model on that basis. They're basically using GPT-4 as the teacher, and then they're using their own whatever open source model as the student. If you control both models, you can do that in a more sophisticated way, because remember that it's not just a single token that the language model predicts, it's actually the probability for every possible token. So that's a pretty rich signal. You've got, in the case of the GPTs, you've got 50,000 plus individual predictions for every possible token for every single generation. So that's a signal that you can really optimize toward pretty effectively. GPT-4 does not give you that. They don't actually give you all of the outputs. They just give you the one token that was selected. So you can still train on that. But if you have both models, then you can really do this teacher-student stuff in an efficient way. And why would you do this? Well, maybe to just narrow in. I mean, obviously, ultimately to save money, right? You want to do this because you're going to have a smaller model at the end, and you can run that for cheaper and faster. But you also might find that this doesn't even really cost you anything. If, for example, you had some general purpose model, and now you just want to create a narrow purpose model, then this can be a great way to do it. You also have, there's like the grokking dynamics of this are pretty complicated. You might be like, yeah, I tried to, train a certain thing into a small model and didn't quite work, but that behavior is there in a large model. Can I maybe get that large model to kind of teach it to the small model? And it's, I don't think this is very well understood by anyone, but it is interesting to kind of think about, maybe the large model can grok certain things, and then maybe the student model can kind of, does it also grok, or maybe it just kind of learns to imitate? Which models have grokked what is like very unclear most of the time. But there are certain things where like you just see that the large models can do them. And so training the small models from the large models, interestingly, can be like maybe the only path to get small models that can do certain things. Probably not the only path, because you could come up with something else, I imagine, fullness of time. But this is like a technique that we are in practice finding is the practically useful way to create small models that can do certain things well. All right, and then one more on the efficiency measures, mixture of experts. So this is, going back to, I think we talked about last time, the concept of sparsity a little bit, especially in the context of encouraging grokking. And that was the Max Tegmark and Jiming paper, where they used a modified loss function to encourage sparsity. Well, this is another way to create sparsity. Why do you want sparsity? Because sparsity can mean multiple things. It can mean just having certain weights that are set to 0. If a weight is 0, multiplying by 0 is always 0. So that saves you having to do some of the computation. Another way to think about sparsity is saying, well, what if I took a certain portion of the network and I segmented it, and then I only used certain segments at certain times? So in this, again, lots of variations on this, of course, but here you've got your kind of classic transformer setup where you've got your attention, and you've got these normalization functions. And then when it comes to the feed forward part of the network, they break it up into bits, and they have this router that says, which ones are we actually going to use right now? And which ones do we weigh how much? So you could have, and again, according to recent rumor, GPT-4 is supposedly a mixture of experts model, where if you count every parameter across all of the different experts, then again, reportedly, it's over 1 trillion parameters. But how many actually get run at a single time is much less, because the router identifies which subpart of the network is best to handle this particular task, and only invokes those or only, actually processes through those that are appropriate. And it could be one or it could be multiple. Again, you could have different setups that handle this different ways. But the point is, you're only going to have to run a subset of those parameters. And so it's going to be a lot more efficient and fast at runtime. So this is still heavy to train. Like you're training, if this is GPT-4, which it's not, but if this, if you imagine this is kind of a stand-in for GPT-4, then you don't save so much on the training because you're still doing a trillion parameters worth of training. But at runtime, you only have to use so many for each query, and that saves you a ton on your inference. And again, where inference is going to be the bulk of the compute, these efficiency measures really, really matter. So, all right, those are all of my implementation trends and lots of discussion too.
Omniki uses generative AI to enable you to launch hundreds of thousands of ad iterations that actually work, customized across all platforms with a click of a button. I believe in Omniki so much that I invested in it, and I recommend you use it too. Use CogRev to get a 10% discount.